For my video assignment, I analyzed the article Visual Aids Improve Diagnostic Inferences and Metacognitive Judgment Calibration by Garcia Retamero, Coakley, and Hoffridge. The background of this article's topic is that visual aids, defined in the article as graphical displays of probability, have been observed to be an effective method of communicating risk. Risk, in this paper, is understood through the lens of risk literacy, that is, how good people are at comprehending situations and making accurate judgments. Previous research has found that individuals have difficulty understanding risk even when it comes to real-world scenarios. One common type of test when it comes to numeracy, that is, ability to correctly internalize risk numbers, is a disease prevalence numeracy test, where rates of illness are provided as an example. A study by Eddy in 1982 posed the following question to doctors, medical professionals. The probability that a woman has breast cancer is 1%. When a woman has breast cancer, it is not sure that she will have a positive result on the mammography. She has an 80% probability of having a positive result on the mammography. When a woman does not have breast cancer, it is still possible that she will have a positive result on the mammography. She has a 10% probability of having a positive result on the mammography. And so, after being given the information, doctors were asked to estimate the likelihood that any given woman with a positive mammography result would actually have breast cancer. This question can be internalized correctly by thinking about an example of 100 women. Statistically, only one woman will have breast cancer, but around 10 women will test positive regardless. And this sort of thinking would imply that the actual answer to the problem to be somewhere around 8 to 9% without even making any calculations, but most doctors still estimated the probability to be around 80%. People are bad at risk decisions. Previous research also states that people tend to overestimate their own accuracy when it comes to risk decisions, especially when it comes to individuals with a low level of accuracy. The hypothesis for this article was that visual aids would improve accuracy of risk judgments and also improve self-estimated levels of judgment accuracy. This study used 108 patients from 4 hospitals as participants and randomly assigned half to complete a disease prevalence numeracy test with a visual aid and half to complete the same test without a visual aid. Participants were then also surveyed on how accurate they thought they had been in their assessments. They measured 3 dependent variables: objective accuracy, measured as the percentage of correct responses to the numeracy test, estimated accuracy as the perceived number of correct answers provided, and metacognitive judgment calibration, which was determined by comparing the difference between objective and estimated accuracy for each patient. ANOVA tests were used to analyze data. Here's an example of the type of visual aid used. And in this example, we can see that the general population is compared to women who may test positive on a mammography as compared to the percentage of women in the general population who actually do have breast cancer. And we can see that this information is laid out visually, so not just simply provided in a verbal form. One major finding of the study confirmed that people are often incorrect in estimating their own objective accuracy. Half the participants reported that they had answered all 3 questions correctly, while only 24% of participants actually did. In this figure, we can see a contrast between assumed accuracy and objective accuracy, where participants actually get worse at their predicting their own accuracy the lower they score. High numeracy participants, on the other hand, are fairly accurate at predicting their own accuracy, and as we can see in this figure, rates of estimated accuracy were similar between both high numeracy and low numeracy groups, regardless of the type of data given. What we can also see from this figure is the difference in objective accuracy between the 2 groups, and although the objective accuracy rates are similar for each data type in the high numeracy group, the rates are wildly different in the low numeracy group. We can see that visual aids greatly increased objective accuracy. What's also interesting is the difference in judgment calibration. Again, judgment calibration was calculated as the difference between an individual's self-estimated score and their actual one. So a lower rate of judgment calibration means that it's actually more accurate. And as we can see, rates of judgment calibration are much lower for the low numeracy group when visual aids are present. This figure displays the various differences in correlation for the data types. And I actually thought this graph was pretty interesting because you can see the arrows of correlation that are drawn depending on the two different data states. So, for example, in the numerical information one, you can see that in A, which is patients receiving information only in numbers, there is a negative correlation between numeracy and judgment calibration, which is to be expected. As numeracy increases, you'd expect judgment calibration to decrease because judgment calibration is the difference between objective accuracy and estimated accuracy. And similarly, you can see that there is a negative correlation between judgment calibration and objective accuracy and a positive correlation between numeracy and objective accuracy when it is only the numerical information shown. And then in the second group, B, you can see that numeracy and judgment calibration aren't even that heavily correlated. It's just a 0.10. But what is correlated is still that negative correlation between judgment calibration and objective accuracy. And so what we can determine by looking at these results is that presenting that information visually does increase that objective accuracy because it's no longer correlated with the numeracy of the individuals. Objective accuracy seems to be its own data point in these results. So I like this graph a lot. I thought it was pretty interesting. Overall, the study concluded that visual aids increased the ability of less numerate individuals to recognize patterns in data and facilitated better reasoning and metacognitive modeling. Furthermore, many patients with low numeracy made incorrect judgments about their own accuracy, which implies the existence of an unskilled and unaware effect, as they describe it in the paper. In terms of limitations of the study, there is actually a section at the end that I thought was really interesting, and they bring up the fact that risk situations were only presented in the false positive disease rate paradigm and not any other numerical format. So they suggest the possibility of future research that investigates their same findings when the information is presented in other formats like probabilities. And furthermore, they note that their sample of participants was less educated than the general population, and future research could determine if the pattern held in more educated populations. There are a few real-world implications for this research. Primarily, doctors consistently have to make these exact same sorts of decisions for patients based on disease prevalence examples. So this research shows how doctors might benefit from visually communicated data as opposed to simply numerical or verbal. And one of the other things they found is that numeracy is not directly influenced by other markers of intelligence like fluid reasoning. So even doctors who are otherwise very intelligent people might fall victim to the biases of low numeracy. And they found that displays and visual aids are better ways of communicating risk in these medical situations. So again, just this real world example possibility in the medical situation. But they also found that it can be generalized to other areas of risk as well. So for example, risks in educational situations or personal safety risks, for example. One example could be like the difference in choosing to, fly on an airplane versus going on a car trip somewhere. There's a difference in personal safety there. And so representing data in a visual form might help people make a more informed decision and a more accurate decision in those types of situations. Overall, the study was phenomenal to analyze. I will now be showing up at my doctor's appointments with a disease prevalence chart for all the symptoms that I've been experiencing. So that was my main takeaway from this. Thank you for listening.